Hi, in this session, we will forecast the sales and quantity of products sold by an online retail store which has markets across the globe. The problem statement here is to forecast the sales and quantity for the next 6 months. So we load the required libraries and the data set and do the basic hygiene checks. We move on to the data preparation part. Using this data preparation activity, we find out that the data ranges between 1st January 2011 till 31st December 2014. So data that we have is for 48 months. We move on to the EDA. We do some EDA now to check the most profitable segments, and as can be seen from the plots in the side pane, the APAC and the European Union markets in the consumer segment are the most profitable. We then go on to check the consistently most profitable segments. The reason we do is that we will build the model for these segments to forecast the sales and quantity as required by the problem statement. So we see that based on the coefficient of variation parameter, European Union consumer and the APAC consumer are the two most consistently profitable segments. Since we have to forecast the sales and quantity, so we use the top two consumer segments and build the model, forecasting model for each category. For example, in the segment 1, the European Union and the consumer, we build the model for the sales and then the quantity, and similarly we build the model for sales and quantity in segment 2, in this case it is APAC consumer. So we plot the time series for the sales category in segment 1, and we see that there is no seasonality. However, there is subtle global trend. So there cannot be any mathematical model that can be built so easily that can match the exact time series that is shown. So what I'm trying to say is that the classical decomposition model we will build just for the completeness sake, and then we will mostly rely on the auto ARIMA functionality. Similarly, for the time series quantity category in segment 1, we see the same pattern. Basically, there is no seasonality, only the subtle trend, and the series is in a zigzag manner. For the segment 2 sales category, we see there's almost the same pattern, and the quantity category in segment 2 in the same pattern. So now we build the classical decomposition model. And we see that the model that we get using the linear fit doesn't match the exact time series. So this classical decomposition model is no good. We move on to the auto ARIMA function. And the prediction that we get is shown in red while the actual time series is shown in black. What this means is the series that we get, or the predictions that we get using the auto ARIMA model, is better than the classical decomposition. However, it doesn't exactly match the original time series. So we pick the ARIMA method over the classical decomposition for the sales category in segment 1. Similarly, we do the exercise for quantity category in segment 1, and here also we see the same trend, and we pick the auto ARIMA model. Similarly, we do it for the sales category in segment 2. And here also we pick the auto ARIMA function. Finally, we do the analysis for quantity category in segment 2, and thus we see that for all the 4 models that we built, auto ARIMA is the best choice, and therefore we conclude our analysis. Thank you very much.